How does hydrogen embrittlement cause stress corrosion cracking? Imagine a metal part working perfectly one day, then suddenly cracking under stress without any obvious reason. What could cause such a sudden failure? One culprit is hydrogen embrittlement. This process involves atomic hydrogen sneaking into the metal, making it brittle and more prone to cracking. When combined with a corrosive environment, it can lead to stress corrosion cracking, a dangerous failure mode. Hydrogen embrittlement happens when hydrogen atoms enter the metal, especially high-strength steels and certain alloys. These tiny hydrogen atoms tend to gather at weak spots like grain boundaries, dislocations, or tiny cracks. This gathering weakens the bonds holding the metal together, reducing its ductility. Think of it like rusting from the inside, but on a microscopic level. Now, stress corrosion cracking occurs when tensile stress and a corrosive environment work together. The stress creates tiny cracks, and the environment accelerates their growth. When hydrogen is present, it makes this process worse. The hydrogen atoms weaken the bonds at the crack tips, making it easier for cracks to grow even under normal loads. One way hydrogen causes this is through a mechanism called hydrogen-enhanced localized plasticity. Hydrogen makes dislocations, tiny defects in the metal, move more easily. This causes localized deformation, which concentrates stress at specific points. These stress points become prime spots for cracks to start and grow. Another process is hydrogen-enhanced decohesion. Here, hydrogen reduces the strength of atomic bonds at grain boundaries or interfaces. This makes it easier for cracks to nucleate and extend under stress. Hydrogen can also cause microvoids or tiny internal cracks that merge under stress, forming larger cracks typical of stress corrosion cracking. Corrosive environments like acidic or sour conditions often produce atomic hydrogen at the metal surface. For example, in pipelines or offshore structures exposed to hydrogen sulfide, hydrogen atoms diffuse into the metal, especially at high-stress areas like welds or notches. These zones become more vulnerable to cracking because the hydrogen weakens the internal bonds. Understanding this interaction is vital for industries like oil and gas, aerospace, and construction. Components made of high-strength steel can look fine but suddenly fail because of hydrogen embrittlement-induced stress corrosion cracking. To prevent this, engineers use materials less prone to hydrogen absorption, add protective coatings, or apply cathodic protection to reduce hydrogen formation. They also control residual stresses through heat treatments and avoid environments that generate hydrogen. Regular inspections with non-destructive testing help catch early signs of cracking before catastrophic failure occurs. In essence, hydrogen embrittlement causes stress corrosion cracking by introducing tiny hydrogen atoms into metals, weakening their internal structure. This makes cracks more likely to form and grow under stress and corrosive conditions. Managing environmental exposure and mechanical stresses is key to preventing these hidden failures and keeping metal parts safe and reliable.